Welcome. This is the Cisco CCNA3-ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Module 14, Network Automation. So this is the last module in this course. In this module, we're looking at things such as cloud computing, virtualization, SDN, controllers, and we're going to talk about some basic software terms. You'll be surprised how many software questions there are on the new exam, so definitely take note of this section because it is crucial to understand if you're looking at taking and passing the CCNA. Alright, so the first section is about automation. So in our course shell, there is a video explaining automation. Basically, it's everywhere. Self-checkout, automatic building environment controls, things that learn, all of our smart appliances, all of that is part of automation. Even autonomous cars and airplanes. All of that deals with automation systems that we encounter that we don't even realize. So basically over the last 5-ish years, we've started to see the benefit of automation. There are many benefits. Machines can now work 24/7 without a break, where a human or an end user has to have breaks. Machines typically are more productive. They can produce data that can then be analyzed and then refined and then again more efficient. Automation allows for the collection of the data. Robots are used in dangerous conditions, mining, firefighting, cleanup. When there might be a contaminant like nuclear radiation, humans can't go there, robots can. All of this allows for the reduction of risk to people. Under certain circumstances, smart devices can alter their behavior, can produce better results than a person can. So right now, I have smart lights, I have a smart thermostat, and I have a smart watering system. My sprinkler will water or not water based off of the temperature of the day. If it's raining today, my grass won't need to be watered, so my water system disables or skips watering today. If my light determine that I'm not home, they turn off all of my lights after a certain time period. So anytime after 8:30 a.m., if my phone is not detected, turn off all the lights. When my phone gets connected to the network, it turns on certain lights because as I'm entering the house, it knows what I enjoy, so it auto sets that up. Same thing with music, same thing with my blinds. So automation is becoming huge. So I kept saying the word IoT. Well, in reality, they are thinking devices. These are smart technologies that can help us. Oftentimes, smart technologies help govern behavior. This is a smart appliance, smart car. It could be many things. It is learning what are common for us, and then they try to adjust based off of what they think we need. Whenever a device takes a course of action based on outside pieces of information, that's when the device is referenced to a smart device. Many devices will interact with one another, as well as things outside of their own network. This indicates that the devices have the ability to alter the behavior based off of the environment. In order for a device to think, they need to be programmed using some form of network automation tool so that they understand how to talk to one another and how to communicate with one another. The next major section is about data formats. In our lesson, we do have a video looking at HTML, XML, JSON, and YAML. JSON, that is one that you really need to review a good amount. Oftentimes, there are JSON-based questions on exams that they love to test on, specifically JSON. So you really want to make sure you understand JSON and the overall formatting of it. So let's try to understand these data formats a little bit more in depth. So first, data formats are simply the way the data is stored and exchanged data in a more structured format. If we're talking web content, it's normally following the hypertext markup language format known as HTML. This is the standard language for web content. There are other formats such as the JavaScript Object Notation or JSON, the Extensible Markup Language XML, or the YAML Ain't Markup Language YAML. The data format that is selected will depend on the format that is used by the applications, the tools, the scripts, what you're trying to accomplish, the circumstances, the way the sun is in the sky, the way the person is thinking about. In reality, each of these core languages have some pros and cons, but that's way outside the scope of this type of content. The big thing is to understand that these are some really common programming languages used in automation as well as programming, JSON being probably one of the most common. So here we have some formatting. The formatting has a specific set of structure and rules with any type of programming and written language. Each data format will have specific characteristics, syntaxes that will include the different types of brackets, for example. So when we do this, and we are looking at square brackets versus parentheses versus curly brackets, that means specific things depending on the type of structured language we're using. White spaces, indentation. Python is very, very keen on indentation, where other languages are not. How objects are presented, how they're represented, the characters, the parameters are important. Objects can have characters, could have strings, could have other data types, could have lists or dictionaries or other forms of arrays. So lists of dictionaries or arrays. Part of this could be how the key or how the value pairs are presented. If it's in a list or if it's in a dictionary, is there a key value, for example? So here we could have a key value. Key value. Key. These are two values. So these are pairs. The key is usually on the left side and it identifies or describes the data. So when we're looking at this, oh, that was my bad. So when we're looking at this, I'm going to erase everything. I'm going to go ahead and do position. That's the key. Longitude and latitude are subkeys describing the value that they are in. So this is a subkey. And this is a subkey as well. That way, we can actually have some meaning to this data. When we're talking about the position, you can reference it in longitude and latitude. Here's some other formatting. So this is JSON. So here we have our message, our timestamp, our position, and our two tabs of longitude and latitude. If you'll notice, we have our quotes, we have a colon, and then we have our quotes for our value. Here we have our keys and our values just separated by a colon. We didn't need the quotes. When we're doing a string like longitude and latitude, we might do single quotes. If we're doing XML or HTML, it's going to have a more specific set of coding. we'll have things like a header XML version. We will have very specific message blocks, our timestamp blocks, our position blocks, and then our sub values down here. Because you'll notice here is our beginning and here is our end. This entire root is the beginning and here's the end. You can see that by the caret with the forward slash. That would denote the start and end portions. JSON is human-readable data format used by applications, transferred and reading data. JSON is very popular. That's the big reason why we need to understand it for web services, for APIs, things like that. When we're talking Python, it's very common. With JSON, it's very easy to parse and can be used with, again, other languages. Not just Python, but Python's one of the big ones. As we grow with additional languages, we have the ability to work with one another. So let's look at the JSON a little bit more. So here we have a generic JSON portion. We have a gigabit 000 interface. It's up, it's available, it has a description. So what we can do is we can actually correlate some of this data. Inside the JSON, we can compare the ISO output to the JSON. Notice that each object has a key value pair. It's a different piece of data about the interface, but it's more about the formatting. So this is the interface. What we identify the interface. So here is our interface name. So here we have the actual name of the interface. Here's what it was identified as. Here's our description. And then here is the description, which again we now have in quotes after a colon. Is the interface up? It's enabled. Value's true. Is there a IPv4 address? This identifies that there is an address, so that's why that is there. It identifies there is an address. Then it looks at the IP address and separates it into IP and subnet or net mask. So we can take a single line of iOS code or multiple lines of iOS code and we can convert it directly to JSON so that we can see the overall structured format. So there are specific rules we need to be aware of when we are dealing with JSON. Some of the characters of JSON, first of all, it's very hierarchical. It means it's about containing nested data. So when we do it, we may have our data, then it will tab in and then tab in. It's going to be very nested. So keep that in mind. It uses braces to hold objects and square brackets to hold arrays. So square brackets are for arrays, curly brackets are for objects. So keep that in mind. Objects. So they are slightly different. Data is always written as a key value pair. So that means we'll have key, colon, value. You see this general structure. It will be something that's the key, colon, a response, both in quotes. That is the way you can identify the key value pair. Alright, some other rules. At times, the key may contain more than one value. This is typically known as the array. So the arrays are going to be, oh, sorry about that. The array is going to be a key with more than one value. In JSON, it's an ordered list of values. Characteristics of an array might be things like the key is followed by a colon and a list of values enclosed by square brackets. And I'll show you that as an example in the next slide. The array is an ordered list of values. The array will contain multiple value types, including strings, numbers, booleans, objects, or other data types. Each array is separated by a comma. So here we have our square brackets. This is the array. Here are these separate values. Here's the comma, comma, comma. So here's a list of IPv4 addresses that look, this is the output. The key is address. Each item in the list is a separate object separated by brackets. So here is an object, here's an object, here's an object. OBJ, OBJ, OBJ. Again, these curly brackets are what separate our objects. When there is a square bracket, those are for the arrays. The objects have two key value pairs. In each object, there's an IP and net mask for all of them. Remember that the array of the objects is a list is separated by commas. So here is one portion, comma, the second portion. So again, I want to reiterate that. The key value pair is an IPv6 address, the IP and subnet mask. They're separated by a comma. The array of objects in the list is also separated by a comma, following the closure or the closing braces of each object. This is an object. 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 The three objects make up the array. Alright, so let's look at a few other types. We have our YAML data formatting, which is, oh, it changed slides again, and another type of human readable data format. It's used for transferring and reading data. The characteristics of YAML include very similar to JSON. It's a superset of JSON. It's more of a minimalistic format, making it easier to both read and write. It uses indentation to define its structure without brackets or commas. Here it is being able to be broken down. So again, the iOS output in JSON. So that's this guy on the right of the screen or left of the screen, depending on how you want to look at it. So this is JSON. This is our YAML. The same data is represented on both sides. You'll see the structured portion with JSON. It's very quote based. It's very bracket heavy. And then here are the addresses and objects. Here's the general array for our IPv4. And then we have individual portions of data. As opposed to YAML, because it basically allows for objects to be one or more key value pairs, the key value pairs will be separated by a colon, which we're already familiar with that portion. So here are our colons. So this is one, this is another, this is one, this is another. So these separate into our key value pairs. In YAML, a hyphen is used to separate each element in the list. So I'm actually going to go ahead and erase everything. So here are our hyphens. So these are separating these elements. So this is one element, this is two element, this is three element, separated by our hyphens. XML data is another type of human readable data format used to store, transfer, and read data application. Some of the characteristics are very similar to HTML. It's standardized markup language for creating web content. It is self-descriptive. It will enclose data within a related set of tags. So you'll have a tag, you'll have whatever data you want, and then you have the end tag. The end tag is denoted by the alligator eating the / or the greater than, less than sign, sorry. Unlike HTML, XML uses no predefined tags or document structure. You can do a key based off of what you need. So the object of one or more key value pairs begin with the tag. So you'll have a key tag, you do your definition or your value, then you end that key tag with a greater than with a /. Here we have XML data formatting with the same general iOS that we seen earlier. We define it as XML. Then we have our interface name, our description. Here is our description. Here's the end of the description. We have if it's enabled or not, and it is. Then we have our array. Nope, So we start off with the IETFIP, and then it tabbed in for our addresses. That's our address portion. And then this is the first portion. Here's our second portion. Here's our third portion. So XML data is again very structured, very format, and it uses these tags to self-describe. So moving into our next section, it's about APIs. Our core shell has things like defining API, giving examples of popular APIs. Our SOAP, our REST, our NET, and reset configs are all described in detail in our core shell using a video. That's outside the scope of this video because I'm not reduplicating the videos found in the core shell. So the API concept essentially. The API is the software that allows other applications to access its data or services. So if we have a kitchen, for example, and that's where the food is, we have someone sitting at the dining room table, they could request food through the waiter. The waiter would then be called the API. They're going to act as the middleman so that you request through the waiter, and then what you get back or the response are coming from the waiter. Everything goes through that middleman, which is the waiter concept. Alright, so let's look at an example of an API. So here we have a data format. We input the data that directly accesses some form of database, and then that returns. So that's a general 4-step process. Again, first portion uses the website to pull in data input. The website interacts directly with the airline's own database to provide the user with information. So that'd be step 2. Step 3 is the return. Step 4 is the actual output. As an API would actually have, you'd enter information and then it would do calls to different databases, different airlines. Not having a single airline, but as many airlines as you want. For the APIs can be open or public APIs, internal or private APIs, or partner APIs. These APIs, if they're public, will be publicly available and can be used to no restrictions. But these APIs are public. Many providers will require their users to get a free key, token, or something to help with that connection. Internal or private APIs, these are used by organizations or companies to access data and services for internal use only. And then partner APIs, that's where you're used between a company and its partners or contractors so that they can share information that way. types of service APIs. We have SOAP and reset. So simple object access protocol, representational state transfer. We have RPCs for XML and JSON as well. You'll notice that the JSON is the newest of them. It's simplistic. The XML RPC is well established, also simplistic. REST and SOAP are also been well established. REST uses a combination of languages. So let's look at REST. Inside our core shell, we have videos outlining REST, HTTP, curl, and more. So I'm not going to reduplicate these videos, but keep in mind these are in the core shell. So REST and RESTful APIs. So you should be fairly familiar with things like our HTTP and HTTPS GET requests. With some of this, I'm going to grab my marker, there we go. So our GET requests for obtaining a web page. If you get a web page with a GET request, you get a code 200. The web server will respond to the GET request with the appropriate coded page. Well, a simple stated REST API is the API that will work on top of HTTP. It will identify and define sets of functions that developers can use to perform requests as well as receive responses via the GET request or our POST requests. Conforming to the constraints of REST architecture, it's generally referred to as the RESTful. APIs can be considered RESTful if they have any of the following features. They're cacheable, they're stateless, or there's a client-server structure. Cacheable meaning that the clients can cache it. Stateless means that no client data is stored on the server. Client-server is basically that a client will handle the front end of the server, will handle the back end. Either can be replaced independently of each other, and they have a clear scope or defined workload. With RESTful implementation, again, the RESTful web service will implement using HTTP. It's a collection of resources, and it has 4 defined aspects. Basically, it has a base uniform resource identifier, or URI, such as http:/example.com/resource. That's 1. 2, the data format supported by the web service, often like JSON, YAML, or XML, but could be other data formats. That's 2. 3, the set of operational supports by the web services has to include HTTP. Also, the API must be hypertext driven. RESTful APIs will use common HTTP methods like post, get, put, patch, and delete, as well as other contents. So again, post is create, get is read, put or patch is update, delete is modify, removal, essentially. The URI, URN, and URLs are also important. So web resources and web services that use RESTful APIs can be identified using the URI. The URI is a string of characters that identify the specific network resource. The URI has 2 specializations: URN, URL, uniform resource name, uniform resource locator. The URN identifies the namespace, where the URL identifies the network location of the specific resource. Normally HTTP or HTTPS URLs, could be FTP as well, or some other variation. So here are some parts of the URI of a broken down example. So here we have the protocol, HTTP. The host name or domain name will be the subdomain, and the domain name and extension. After that, we have this portion. This is the path and file name. After that, we have our page 155. That's the fragment. That's the a specific identifier. So again, the anatomy of a RESTful request. Here we have our API. Here is the resource. Here's the format. Here's the key. Ampersand. So here we have our format or our query. The ampersand lets you know it's part of a query because that's standard formatting. So this will show the URI for MapQuests. It's pretty sad that we are doing MapQuest, but it is what it is. So here's the anatomy of a RESTful example, a little bit more in depth. So let's look at this again. We have our API server. We have our mapquest.com. This is the URL for the service answering the requests. We have our resource directory before the question mark. We have our query, which is going to be the format. This is usually a JSON, but could be XML, could be something else. However, in this example, we're using JSON. For JSON, that's going to be the entire query string broken up into key parts. We have the format portion, question mark to the ampersand. We have our key, and that's going to be to the ampersand. And from our ampersand forward is going to be our parameter. That's going to be our return search string. Many RESTful APIs will include, again, public APIs. Those require keys. The keys will be used to identify the source of the request. Some of the reasons for API providers requiring a key is to authenticate, to limit the number of people using the API, limit the number of requests per user or per location, to better capture and track data being requested, to gather information on people using the API. For example, we may have an API calling into an inventory system. The API key might denote which organization is being tied to that development site. That way, you know what, let's just draw an example on the bottom. So we have a warehouse that has inventory. And we have Walmart. We have Amazon. We have other miscellaneous vendors. Well, each of these APIs will call in and will have direct ship items. Well, the warehouse can see how many orders are coming in for Walmart, how many orders are coming in from Amazon, how many orders are coming in from these miscellaneous providers. That way they can see who actually has the majority of their business. That way they may say, well, Amazon is only allowed X amount of orders, or Walmart's only allowed X amount of orders. That way other vendors might be able to better capture some of that. All of this is so that we can limit or track the numbers of peoples and or requests coming in. That's the entire purpose here. And all of this is part of the software-defined networking section. We have other RESTful applications. So many websites and applications will use the APIs to access information as well as provide services for their customers. The RESTful API requests are made by typing in the URI from the website. Example like MapQuest with directions. That is a RESTful API so that it can request information. We can also use APIs for development websites, Postman, Python, or other network operating systems. Our network operating systems will use such protocols like netconf or restconf. Our Postman is an application using REST APIs, and they'll contain everything required for constructing and sending REST API requests. Our developer sites, again, that's going to be maintaining web content that include information about the APIs. Also, we have things like our Python program that's allowed for automation, customization, and app integration. Our next major section is configuring the management tools. We have a video covering the management tool section in our Core shell, that's going to be things like SaltStack, Ansible, Puppet, and Chef. These you do want to do separate readings on, because you are going to be asked questions about these on our CCNA exam. So you do want to make sure you understand what they are. Our traditional network configuration might be done via a CLI or terminal connection between our routers, our layer 3 switches, and our layer 2 switches. Network devices have been traditionally configured for this. However, there are issues as the network grows and the configuration becomes more complex. This is not always the best way to do it. We now have things like network management stations, or NMSs, using SNMP that will help deploy the configuration. SNMP allows for simple, more elegant development of our configurations. SNMP is not typically used for configuration because it has some security gaps, but you can. You could also use APIs to automate this process. APIs to automate the deployment, the development, the management of the resources, instead of having to manually configure ports, access lists, QoSs. All of that can be done through APIs as well as part of the automated development process. Part of our network automation uses things like Chef, Puppet, Ansible, Python, RESTs, our SaltStack, or JSON. All of that is used to develop and automate our code development even faster. Alright, so our next one is going to be about configuration management, focusing on RESTful API requests that help automate. Again, the administrator benefits for our automation is going to be things such as our software and version control. Oh, not wanting to give me back my... Alright, so we have our software and version control. Device attributes, naming and addressing and security, you can make these more uniform. Our protocols and our ACLs and other configurations, again, uniformed. The configuration manager tool will typically include automation and orchestration. Automation is where the tool automatically performs the tasks on the system. Orchestration is the arranging of the automated tasks that result in a coordinated process or workflow to better understand or to better complete the task. Because the system doesn't really care about understanding it, it's more about completion. Our configuration management tools for making configuration management easier are Ansible, Chef, Puppet, and SaltStack. Again, these are 3 or 4 that you really need to go into a little bit more in depth so that you understand them at a much better level. I'll probably be doing separate support videos for this content because just a brief overview is not going to cut it on the actual exam. So, characteristics. Ansible does Python and Yam, Chef does Ruby, Puppet does Ruby, SaltStack does Python. Are they agent-based or are they agentless? Ansible is agentless, Chef is agent-based, Puppet is both, SaltStack is both. How many devices can be managed? So basically with Ansible, any device can be a controller. With Chef, we have a Chef master. With Puppet, we have a Puppet master. And with SaltStack, again, we have a master as well. The tool is created through playbooks, or through a cookbook, or manifesto, or pillar. Basically, you need to understand the names and kind of the purposes of them. So when you talk about Ansible and we're talking about the playbook, that is basically what created the tool. When we're talking about how the devices are managed, then when you think controller and Ansible, that way you understand kind of what the purpose of the name is based off of the characteristic. We have our IMB and our Cisco DNA Center. Again, we have an internet-based network video as well as a Cisco digital network architecture, DNA, video in our course shell. Again, these are ones that you want to dig deeper in because these are ones that are typically new to most individuals, and I'll be doing separate videos for these specifically because they need way more level of detail than a brief overview that our chapter did. So our internet-based networking is basically, it's an emerging industrial model for next generation networking. IBNs build on the SDNs, software networking, and they transform hardware-centric and manual approach design and operating networks to a more software-centric and fully automated one. When we're talking our routing, we don't need to worry about buying a physical network router. We can have a software-defined router as part of our SDN network. The business objectives for the network are expressed as intent. The IBN will capture business intent and use analytics, machine learning, and automation to align the network and dynamically adjust the business needs. So as the business needs changing, then the network can then realign. IBN captures and translates business intent into network policies to automate and apply consistently across the network. IBM captures and translates the business intent into network policies. That's IBN. That means they capture and translate intent, and they transform that into our network policies. So here we have our IDN again, broken down into our translate, activate, and assurance. Translate basically will translate the function. This will enable the network administrator to express the expected networking behavior. The activation will basically be the capture intent that needs to be interpreted into policies. The assurance will basically the order to continuously check that the expressed intent is honored. And then we go in a circle. We start with our translate. That's where we say our needs. We do the activation, goes into the physical infrastructure, and then we double check with assurance. And if there's modifications, then we go back through translate and we just keep running through it. All of this is known as the network infrastructure as fabric. Basically, from the perspective of the IBM, the physical and virtual network infrastructure is a fabric. It's an overlay that represents the logical topology used in virtual connections. The overlay will limit the number of devices that the network admin must program and provide services, as well as alternate pathing methods for not controlling the underlying physical devices. Again, the goal is not to program every individual device, but to do it at a higher level and let the automated software handle the underlying layers. The overlay is where the encapsulation protocols like IPsec or CAPWAP will occur. Using an IBN solution, the network administrator can use policies to specify exactly what happens in the overlay control panel. Notice that this is where the switches are not physically connected. It's not a concern of the overlay. Again, we're only looking at high-level concepts instead of having to look at all overlays. Alright, so moving on, we have the underlying network is the physical topology. That will include all of the physical connections. The underlying reveals the additional devices, and that is what we're trying to avoid dealing directly with. Part of this is taking the management tools and letting them configure the physical portion. Cisco has implemented the IBN fabric using what's known as the Cisco DNA. Basically, the business intent is to secure deploy into the network infrastructure, i.e. the fabric. The DNA will then continuously gather data from multiple sources and then make necessary modifications. This information can be then analyzed to make sure that the network is performing securely at the optimal level and in accordance with the intent, network policies, and any compliance requirements that are necessary. Some of the Cisco DNA solutions are things like the SD Access or SD-WAN, and that will allow for software-defined access. The first intent-based enterprise network solution built by Cisco DNA, our SD-WAN, will use a secure cloud delivery architect. We have our DNA assurance and our DNA security. And our DNA assurance basically is used to troubleshoot and increase IT productivity. DNA security is basically used to provide visibility by using the network as a sensor for real-time analysis and intelligence. Part of the DNA Center is the foundation controller and the analytics platform at the heart of the DNA product line. It supports the expression of what the business is trying to do. What is the network trying to do for multiple cases, including basic automation. Cisco DNA Center is a network management and command center for provisioning and configuring all of the devices. The hardware and software platforms provide basically a single pane of glass or a single interface that focuses on the assurance, analytics, and automation. The DNA Center will interface, basically will give you a page for you to see the overall health summary and network snapshot from anywhere. The network administrator can quickly drill down into areas of interest if they want to. Here's an example of the DNA Center. You can see the design, the policies, the provisions, the assurance, the platforms, and all of this will give you the visibility that you are wanting. There is a video in our lesson covering the DNA Center as well as the GUI. There's a video looking at the design and provisioning as well as the center policy and assurance. There isn't anything that we can do without the appropriate configured software, and realistically that's not something that we have available. It's more of a understand the core concepts of it so that you can answer basic questions. When you get into a larger certification course, they'll provide the infrastructure to actually review all of this. Lastly, we have a video looking at troubleshooting, and that is all for this module. We looked at a very high level of programmability languages like JSON, XML, and YAML. We did the smart devices, what automation is there for, the purposes of API, the forms of API, the forms of web services, the purposes of our REST and RESTful APIs, how APIs use common HTTP methods like post, get, put, patch, delete. We looked at the different APIs and the different protocols and technologies such as REST, Ansible, Puppet, Chef, Python, JSON, XML, YAML, and more. We looked at the configuration and orchestrator for the automation tasks, looking at IBN as well as the Cisco DNA centers, and understanding how the IBN is built on the software-defined networking. We then looked at the IBN and how it relates to the DNA Center, understanding that the IBN is the fabric that the DNA Center is built off of, trying to make sure that we understand high level as opposed to just understanding all components. And that is all for this module. If you have any questions or any concerns, please feel free to reach out. If you have any questions or anything, please feel free to reach out. Again, with this material, being able to ask questions and discuss some of the topics in the lecture help build long-term retention, so do not be afraid to communicate with this topic. Again, I'm here if you need anything. Thank you.